Excellent. So I believe we're now live. Cool. Well, thanks for taking time to connect. I know last week we had talked about chatting a bit about Dask on HPC. Unfortunately, NERSC is actually down today, so I can't really demo much. I mean, we can chat about a few things, but I think like if folks are okay with maybe postponing some of that conversation until next week when we can get a demo up and running. But if there's other Dask related stuff, like yeah, we can definitely chat about that. I don't have. I was hoping to have a demo.
I'd be keen to have a quick chat just around if you've got some examples of your scripts or anything of how you actually go about launching it on your cluster to make sure it runs.
Yeah, okay.
Rather than just not.
For sure. Okay, so then let's, I'll update the notes here and I'll add that to maybe the longer discussion items and we can go through, I can show you like a quick example of what I'm doing and then
yeah.
we can chat a bit more and then, yeah, go from there.
Sounds good.
Cool. All right. So do folks maybe want to start with just like quick, quick updates. Are there anything people would like to briefly report, things you've been up to?
Well, yeah, I'll go first. The simulation JK pull request, I just have to go through and I think I just got to add Dask so the tests will start running clear. That and just on the IP side, I was wondering if I go and run a preconditioner, it's to kind of run the IP the same as the DC, and when it calls for the JTJ or like the sensitivity matrix, should it just look for, or should it just use the code from the resistivity side? Or would I even run like a preconditioner or something with the IP survey?
I would say yes, you will need a preconditioner, but we'll have to look at the code to see where it's coming from.
Okay, because right now it doesn't have a JTJ diag. I guess it just uses its the JT vex and whatnot. But does it really have to calculate it already before the DC, or because the DC already has it?
I'm a little bit confused because can you ask one more time? I wasn't sure.
Oh, okay.
Exactly.
So if you run DC and then the IP right afterwards, since you've generated the sensitivities already for the DC side, does it have to be done on the IP?
No, you can use the sensitivity, same sensitivity generated in DC in the IP. So like you just need to set that up in the IP problem. Like you got the J matrix. So yeah. you can actually set that up in the IP problem. So you don't have to regenerate it.
Okay, cool. Yeah, I don't have to do anything on the IP side then. Everything should be handled.
Yeah, I'm not sure, like, because like you have some sort of like a specific implementation about JVec and JTVec using Dask. So I'm like, you probably need to take a look how the IP code works. But I think in theory it's supposed to work, I guess. But I'm not sure the previous implementation sort of like kind of well interconnected with what you've done. So that part I'm not.
Okay, I'll run a quick scan through there and see if there's anything affected. And yeah, other than that pull request is pretty much ready. I'll hit somebody up for a review when I get that looked at.
Where's the IP part, John? Where are you?
Okay, I don't have that up here, but if you go into, I guess it would be under.
Induced polarization. Yeah.
Yeah, under the simulation there, where I guess that's where we put the get JT diag, and it doesn't have one. So if the preconditioner tries to ask for it, should it be directed towards looking, or I guess the DC sensitivity?
Yeah, looking. I'll have to look into it, John. I'm not sure. Yeah.
Yeah, we can do it. We can throw back, or we can go back and forth on that here in the next little bit.
Sounds good.
And then other than that, I got the MT synthetic survey going on the simulation branch now too. It's just like the UBC one with the L-shaped block. Devin and I were looking at that, so I'm going to pass that on to him when I guess I get a hold of him.
But it runs, and you're getting similar fields.
Yeah, getting similar fields, getting similar results. I do kind of have, maybe there might be a polarity issue in the one. I just got to make sure that I have my the components lined up right or pulling out properly.
The usual problem.
Sorry?
The usual problem. What is X? What is Y?
What's up and down?
So yeah, I think that's the only thing I have to really confirm on it, but it's running and it goes. It's you can't really run it on a laptop. It still takes about 15 gigs or so, or I guess it's a little bit slow is what I'm saying. Without the tree mesh, it's inherently slow. And I think I started a problem on that or something like that, where see what we can do about getting all tree into it.
Excellent. And have you? Yeah, I think the octree will take a little bit of thought just with the boundary.
As long as you use the nodal discretization, I don't think that's a problem. So it's basically same like for nodal discretization. Natural boundary condition is Neumann. So yeah.
Oh.
If you want to use an octree code, use the nodal problem N, not CC.
Oh, okay, I'll have to check that. I'm probably on cell centered, I bet. Yeah.
That'll be better because like the DC, if you use the problem CC, your boundary condition is Dirichlet, which is like probably a little bit bad for like general like a surface DC problem.
So we're talking about MP though.
Oh, I see. Oh, sorry.
No worries.
I thought I was a little confused there. But
Yeah.
Yeah, empty. I think none of the boundary condition. I think it's all like secondary field formulation. So it's supposed to be zero.
Yeah, so it should, in theory, work out of the box. I think.
Oh. Okay. I'll double check it and see if I'm
That's
using
for trying.
Yeah.
Yeah.
For that part, it shouldn't matter. I guess it should be pretty similar.
Okay.
Yeah, that's awesome, John. That'll be extremely useful. And then having actually so we're getting some strange feedback from someone. I sound like a duck. So if you guys don't mind muting if you're not talking, thanks. So that'll be extremely useful, I think, also because one of the things that would be nice to do is refactor the MT code to be much more heavily integrated with the frequency domain EM. That'll take a bit of thought with respect to sources and things like that. But having a couple like slightly more complex examples that we can continue to run to make sure that we haven't broken anything in the refactor, that'll be extremely valuable. Excellent. Anything else, John? That's a lot of things, so you can say no.
That's all for now. I got a few other things that I want to try, but one thing at a time.
Fair enough. That's awesome. Yeah, feel free to ping on the PR, and I'm happy to jump in and maybe Dom. I know you've been sort of in the loop on that too, so maybe between a few of us, we can help give some feedback and hopefully get that moving. Excellent. Cool. Who else would like to give some updates?
I can say what I was working on. So back to the tile problem. I thought I had a solution, but turns out that it doesn't work if it didn't work if we wanted to if the local meshes had smaller cell sizes than the global mesh.
Mm-hmm.
It works well if we always homogenize from the global problem to the local problem. But if we have a mix of the two, the interpolation of sensitivities was just crashing. It's not crashing, but it was just like not giving good results. So on my personal branch, with all the potential fields people, it would be nice if everybody upgrades, because now the way I'm creating the global mesh is after creating all the local meshes to make sure that the global mesh always has the smallest discretization, if that makes sense. And just really only deal with a case where we're homogenizing upward and not down. And that's that. I don't have any more better solution in terms of interpolation. That's just, it has to be that way for now. And so now that I'm pretty happy with the tiling problem, John provided me a script to do the DC, to run a DC example. So I will implement probably this weekend the tile DC version.
Excellent. And Dom, what is the branch that you're working on? If people are on,
it's my good old Frankenstein magdev df_desk. Yeah, I'm pushing on this one.
okay, mag dev pf.
magdev_df_desk.
Okay, cool.
So I think the tile map should come in on its own. And I probably want to do it outside of the simulation.
Yeah, that's fair.
So, well, for now, I guess, John, we can just create like a temporary branch of your simulation JK and add the tile map to it, and then run tests. But hopefully we can have a PR just for the tile map ahead of you.
And do you want that PR for the tile map to go onto the simulation branch, or should that go onto master?
Okay, well, I was thinking master, but it's not a bad idea. We could just do it on simulation too.
Well, if it's like tight enough that it can go onto master, then let's do that. And people who are using SimPEG right now can do that, and like there's no problem pulling it upstream.
Yeah.
Yeah, the simulation is like a bit of a Frankenstein. So if we can sort of keep that somewhat scoped.
I think so, yeah. Yeah, so I was thinking let's just go to masters and then have a simple example on Octree meshes, because now it's all in, right? So we can do that.
That would be great.
I have a question for you regarding Joe, regarding the interpolation, right? You started working on this, the volume averaging. Yeah. So I have an implementation in the tile map, which is probably not the fastest, definitely not the fastest. How far are you from having like a mesh-to-mesh interpolator?
I mean, I'm really close. I've got it working for tensor meshes.
Okay.
And like I still just haven't, I know exactly how I need to do it for the tree mesh. The idea is that we take the tree mesh and then I have to go down to the underlying tensor mesh that the tree mesh has. And that volume average from that to the finest discretization essentially. And then since I have a tensor mesh code, I can just use that to link the two.
And that's not going to blow up memory when we go to the underlying finest cell?
It might. I'm not quite sure yet. I'll have to play around with it. But I mean, that's my only concern.
Yeah, that's what UBC is doing, and it's totally like a bottleneck, because you know.
And I just don't. I'm not quite sure. I mean, I could probably get around it without doing a bunch of memory, using like the tree mesh itself. I could probably get around it. I'll have to think about it for a bit.
Well, for now, I'll just put in the implementation that I have, and then I guess we can swap the interpolator. Yeah.
What's the interpolation issue you were running before? Were you just doing like self-centered interpolation?
So for Octree, for tree mesh, if we're assuming that we're always homogenizing one way, then I'm just doing a cell containing cell, right? So I look for cell centers that are inside, and then I
and then self-centered interpolation, yeah.
Well, then I can do a volume averaging on it.
Okay.
Once I know the corners and I know how much partial volume in it and whatnot. It's more complicated for For tensor mesh, I don't have a good answer for tensor mesh. I'm just doing like a search, a radial search, but really robust. Yeah.
I mean, if you look at like I've got the simple tensor mesh, the tensor mesh one implemented in there on that branch.
Yeah, maybe I'll put
that.
Which branch are you on?
It's in discretize. There's a volume average branch. It's like.
Okay. I'll look it up. Volume discretize branch. Okay, I'll look it up. Sweet.
Okay.
Maybe I can just that part for now.
TileMap is working on octree to octree. Is that the setup now?
It should be working on all meshes. It shouldn't matter. It's just the tensor interpolator is not super robust, but yeah, maybe Joe has a better implementation.
Right.
It seemed like it was working very well. I was talking. I put it through a few tests with.
I don't know why, Sagi man, your mic is giving us so much feedback. Okay. But go ahead, Joe.
Sorry, I put it through a few tests with what's his name that I was working on it with.
Dieter.
Dieter, yeah. I wanted to say Dieter, but yeah, he put it through a few tests, and it seems to be working well on his side. And it was really like a lot quicker than what he had implemented himself. And
yeah, he was for looping, right? I saw the initial implementation.
Quadruple 5 for loops, and it was like.
Yeah.
It got it like I think what he had before was like 1.5 minutes, and I got it down to 3 seconds.
So I'll see. I have one more thing to. I have a PR on SimPEG, and this is my catching up my mistakes that I've done in the past. So Lindsay, if you could bring this in as soon as possible, because it's really improving the issues we had with the simple and sparse regularization. And it has to do with the length scales, right? So after finding a better way to do it, this will really improve the inversion. So if we can bring this in, that'll be great.
I can try and take a look this afternoon and/or like tomorrow morning. So yeah, let's get that in this week, and feel free to poke me again if you don't hear something soon.
Yeah. I mean, it's tiny. All the tests are passing.
Excellent.
Examples look better, so I don't think it's I think it's a no-brainer.
Perfect.
That's it for me.
Thanks, Tom. Cool. Anybody else have updates?
Is it making a lot of noise?
It's only when other people talk. So like if you're talking, it's fine. But if I'm talking and you're unmuted, then it's not fine. But if you want to give an update, that's totally fine.
Okay. Sounds good. Yeah, I'm working on AEM problem, airborne EM problem, parallelizing it. So I got actually a draft code working, and I was currently starting from like just multiprocessing, and yeah, Sim's task is okay. So the important portion to me was actually writing the inputs into the disk. So I was looking at what John and Dom did using ZAR, which looked pretty good. I really liked it, how that was implemented. But that implementation was really nice when you got really big sensitivity matrix, because like that's the bottleneck. Like you got really big problem, big sensitivity matrix, you want to generate it, but you don't want to store it. So you want to just load it up on the fly. But airborne EM problem is not quite like that, because local sensitivity is pretty small. So yeah, like it's a little bit different. I don't need a ZAR to store it, but I just pickled like meshes and other things, all the inputs that I need. And basically, whenever I'm parallelizing it, I'm just writing things up and then loading it up whenever I need to compute. So I think in that way, Dask was actually fine. It was almost comparable with multiprocessing, because I think a lot of crazy things happening if your input is large. So that's something that I had, I guess. So the efficiency was pretty bad for Dask. So, but once you write things up, it seems fine. So I'm actually looking forward to. I mean, you could choose either one. Like you could, if you are working on a single cluster, multiprocessing is actually better. But if you're working on multiple clusters, lots of computation, maybe you may want to use Dask. So like that. So I'm not sure. Can let me see, share. Can you guys see that? Can you see its screen?
Yes, that looks good, Sagi.
Okay, so this is the tensor mesh that I'm working on. I got 200 by 40 by 100, and I got 1,000, about like 1,200 stations. So I can write things on disk, and I can run. So it takes about 3 minutes. I used a 16 CPU. So yeah, I think that was about sort of my goal. Like, okay, if I can handle like a couple thousand soundings and finish the simulation in a couple of minutes, that's actually good. And then if you had more resources, that can go down much faster. So if you got 100 CPU, that'll be much better. But anyway, so that's where I am. I just wanted to share where I was. I think if you're sort of parallelizing the DC, I think you may need to do similar thing that what I've done, because like once you kind of make a local mesh, it's not that even like if you do a line by line DC, it's not, your mesh is not going to be that much big. So you can use a ZAR for sensitivity portion, but other things, I think you don't have to use ZAR, I guess. I'm not, yeah, I don't know. I'm not sure exactly, but just a thought.
UBC, I'm just going to mute you guys. We're helping out quite a bit, but feel free to unmute if you have other things to bring up.
So Sag, what are you storing on disk? And yeah, what are you storing on this? And this is for the forward, right? So what are you going to do for the inverse?
So my main storage is actually a mesh. So I got 1,000 mesh. So like a 1,300 mesh. So that could be quite a bit, and if you're loaded up in a memory. And like I want to handle like 100,000 mesh. So that's something that I want to load it up, everything into the memory. So that's the main thing. But I also have a map. So mapping is another giant, because if you're generating a mapping between a global mesh to local, and then you need to store global mesh for each 100,000 soundings, which is not good. So I had to do something about that as well. But anyway,
you store the mesh or just the interpolator, right? Just a projection.
Correct. I'm just like storing an interpolator. You don't have to do a. But like if you're storing a mapping, then it always stores the mesh, global mesh, which is not good. So that's what I was kind of preventing. So if you're just using like a naive mapping structure that we have, you're going to get really big memory because of the mapping.
That's a good point, Sagi, and that's something, I don't know if you've had a chance to maybe document in an issue, because one of the things that we could do is generalize that piece so that like instead of actually storing the global mesh on the mapping, we store like basically effectively like a pointer to the global mesh that's maybe written out into a single file. And so having us be able to like go back and forth between sort of the naive usage and then actually sort of your smarter use case where you only want one mesh file written out would be nice. And that should be fairly straightforward for us to do like actually at the SimPEG level, so that you don't have to like implement extra machinery.
Correct. Yeah, I think I haven't tried yet. Idealistically, if you can pickle problem, that'll be sort of the easiest way, because like in the problem, it includes everything that we need.
Yeah.
So if you can pickle the problem, store it, and then just like bring things up whenever it needed, I think that's probably the easiest way to sort of parallelize, because like just need to write everything and then just load it up while you go. And then if you want to use Dask, I think that seems like the sort of the best way. Otherwise, like communication makes like kind of things crazy.
Thanks, Sagi. Anybody else have updates? Folks at UBC, Joe, or anyone else?
Ren, you were going to say something.
Yeah, just a small thing. I want to say that I started with Devin's help to do this kind of comparison between Res2D-Inv and DCIP2D and SimPEG. And we're using the GIF synthetic model, although we could use others as well, presumably, as well as I think a hydrogeologic data set from Max at Boulder. I think he got it from Surrey nearby. So that's, yeah, we've been starting that. We got some results so far, but yeah, it's ongoing.
So Sagi, the plan there is probably just one more day of a little bit of testing here on the example with DCIP2D, and then be ready to send you the files, and then you could try the SimPEG version. We could then compare those results.
Sounds good. Did you guys sort of sketch out how the app would look like?
Not quite, but we're kind of getting there. I mean, we've got, yeah, some of the basic ideas that we think we'd like to see. They kind of parallel pretty much what had been in the previous, in the previous GUIs. So, but we can fine tune that a little bit more. But I think the first shot through is just to check the numbers and make sure we've got the same results.
Sounds good. Is there anything else that you guys need for sort of getting material prepped, or sort of thinking through the notebook structures that we want to deliver?
We just need visas.
Right.
That's been a preoccupation.
Okay, fair enough. I can't help it.
Yeah.
I think we're probably okay. We should probably within the next day or a couple of days, if there's stuff that comes up. But I think the most important thing right now is to make sure that we've got the the SimPEG DC forward modeling and inversion up. We have cross-checked the numbers. We know what the inputs are and the outputs, and then we can fine-tune things. So yeah, Ren's been looking at some of the existing apps. I think most of those they're pretty good to go.
Yeah, Doug just showed me all those EM apps in GeoSci Labs. And just to clarify, did the name of it change? Like GeoSci Labs, and then there was a hyphen inside? I was a bit confused.
So we have a couple libraries. So I don't think the name of that one has changed. But the way that works is like the GPG Labs basically copies a subset of GeoSci Labs, and then same thing, EM Apps copies a subset of GeoSci Labs. So GeoSci Labs is like the app warehouse basically, and then these other repositories are scoped for different audiences. So GPG Labs is like meant to be basically what is needed for 350, and EM is like only EM. There shouldn't be any like mag or gravity or anything like that in there.
Okay. Yeah, well, I've been looking through them. So.
Excellent.
Did Soggy just leave? We've just got his name on the screen.
Oh,
I'm
good.
here.
Oh,
Bold statement.
you're back.
Cool. All right. Any other updates? Craig, is there anything you wanted to update? Or I know we want to chat about Dask, but do you have anything else you wanted to jump in on?
No, not really.
Okay.
The Halimag paper I submitted like months ago is finally in review as of about 2 weeks ago. So
Congrats.
maybe in a few more weeks we'll get something back on that.
Excellent.
But no, that's about all.
Cool. Well, that's great. Well, keep us posted on your paper. That's exciting.
Yeah, we'll do.
So I guess I can give a couple quick updates. So I'm at GeoHack Week this week, so I'm in Seattle right now. Getting connected with folks. I gave a tutorial yesterday on Jupyter and using notebooks. And so actually I based it on some notebooks that Fernando used for ISAT2 Hack Week. And they're actually they're a really nice set of notebooks. And there's a couple things that I actually learned just going through like the very basic vanilla Jupyter notebook tutorial. So I'd actually encourage folks, if you have a few minutes, just to like flip through. I'll drop the link in the notes. Yeah, because you might pick up some things. You might pick up some things that are useful. For example, I didn't know that the underscore is actually reserved in Jupyter. And so if you type content in a cell and then you type underscore below that and hit Shift Enter, the underscore actually is the output from the previous cell. And if you do 2 underscores, it's from the second, you go back 2 calculations. And so that actually is really handy if, I've accidentally set up and run like an expensive computation and then forgot to assign a variable to it for the output and didn't realize that you actually still have it in your namespace. So I learned that giving a tutorial yesterday. And so I dropped the link in there for GeoHack Week. There's some interesting stuff in there. So if you're actually looking at, if you need to be doing stuff that involves mapping or shapefiles or things like that, there's a ton of useful tutorials that have been created by the instructors here. So it's worth just like flipping through that GitHub organization if you're in need of resources. Okay, I think that's all I have for updates. So I'll maybe flip over to Dask. Job queue is actually, I think, the specific thing that I'll talk a little bit about. I was hoping to do a demo, but NERSC is undergoing upgrades, so I can't even actually access what I was doing, but I can show you the notebook and we can chat through it briefly. It's a bit all over the place because it's very much like a research notebook at this stage. But I'll show you what it looks like, and then I'm happy to create actually like a more cleaned up demo for next week that I can share. So I'll drop the link in here, and then I'll also put it in the notes. Yeah, okay. So let me share my screen. Okay, so you all can see that hopefully. Okay, cool, thank you. So this notebook, I've been going through and building up some stuff for some casing simulations. So like that's the context. So I've been setting up, I created a little wrapper library that makes it easy for me to make meshes that are sensible for the casing. So that's what this casing sim is. So all of this stuff up here is just like setting up my simulation, setting up my mesh, all those standard things, plotting the mesh in the model. Where things start to get a little more interesting on the Dask side of things is right around here. And so in this case, when you want to run Dask, when you want to spin up remote workers, you want to be using Dask job queue. So if you're just using Dask, it's going to spin up workers on the machine that you are currently operating on. If you use Dask job queue, you can actually basically tell it, this is how I want to submit a job. And then here, you also are going to need to set up a client. So in this case, NERSC uses the Slurm job queue. And so here I've been using, set up a Dask job queue. I set up a Slurm cluster. Craig, what kind of job queue submission do you work with? Oh, are you still there? You are muted if you're trying to talk. Did we lose him? Okay. We might have lost.
We're using PBS, Lindsay.
Sorry?
We're using PBS.
Okay. So if you look, these are the Dask job queue docs. So jobqueue.dask.org. So you can actually go in and see configuring Dask job queue. I think they have example deployments. So here they show you how to set up a PBS cluster. So Sagi, if that's what you want to be using, or what you need to be using. I'm using a Slurm cluster, and yeah, so this is a good resource page on how to basically set up that cluster. And then what you can do from there is here I actually just print out the job script. So this is actually like what the Slurm job script looks like. So if I was running into problems with this job submission, I would basically screenshot this and send it to somebody at NERSC and say, hey, this is what I'm trying, something's going wrong, because this has all the information that they need. But you can see specific things like here. So I asked for 120 gigs of memory, and it gives me 112 because there's some overhead. But that's what the submission looks like. Then the next thing you need to do is create a client. So here, if I am doing it with my cluster that I've just created, we ask for that to be set up with the cluster. Otherwise, I would set that up locally. And then here, that gives you then your dashboard. So I don't know if people have seen this. This link is not going to show us anything constructive right now, but this actually shows the Dask extension. And so you can go in and see there's some really cool demos, and hopefully next week we can show one where you can actually see the memory usage. You can see the tasks that are being submitted and being processed and things like that. So then what I've done is I've created the function that I basically want Dask to consume and send over to these HPC nodes. So what I've done is I'm going to import. You need to include the imports inside that function, because you're basically getting a brand new cleaned namespace. So I include the imports inside the function. And then here, to Sagi's point, what I'm actually going to pass is just the serialized versions of these classes. So I'm not actually passing an object. I'm going to pass the serialized JSON. Or alternatively, you could serialize that to a file, to a pickle file or to a JSON file or HDF file, whatever you want, and load that up in the script. So here I have, and then I think M I'm just passing actually as a NumPy array, which if that gets large enough will be very inefficient. But for now, that was not enough of a bottleneck that I needed to think it through anymore. So then with my simulation parameters, I actually go in, oh no, I was passing M, sorry, as JSON. So here I deserialize, so that basically recreates my simulation object. And then we can go ahead, set up the simulation as normal. And then the thing that I do is I actually just save the fields as the output, and I return a file name of where those fields were saved. So that's all that function will do. I then need to, before you perform a computation, you have to scale your cluster. So you have to say, go grab me some nodes. In this case, when I do that on NERSC, it's actually going to like stick me in the job queue, basically. So that's scaled. And then here we can go in and actually run or set up the script to run. So here I've wrapped my simulation with a dask.delayed. And then here, when I actually go in and run, I do dask.compute. One thing that's important to know, and I think Dom's pointed this out, you need to be careful, like not to be repetitive with dask.delayed. So here in this case, I originally was using the decorator, but then just for testing some things out, I switched to putting it inside a function handle. You don't want to do both of those things at once. But if you needed to, for example, if I was doing a for loop inside of here and I wanted to parallelize that as well, you can actually do that with Dask. So you can have nested things that are parallelized, and it'll compute the tree structure and like how to actually do that. So that's all totally fine. Do people have questions on that? Or Craig, was that?
Lindsay, where are you running this?
So this, the notebook, NERSC has a Jupyter lab or a Jupyter hub that I can log into. So I log into like the login node of NERSC, and then I can run in the Jupyter, like on that Jupyter queue. So that's sort of limited memory. It's a shared node. But then when I actually request Dask, when I set up my Dask cluster, I can ask to be put in whatever queue. So in this case, I asked to be put in the debug queue because those are a bit faster. And as long as your computation is under 30 minutes, then you can access those. But if you needed a bigger submission queue, then you could change this to regular or whatever queue you should be in.
Thanks, Lindsay. Yeah, that's cool. That answers a few questions I had. I think I'll have to have a bit closer look at your notebook for the details, but yeah, I remember that thing about not kind of double wrapping Dask delayed being an issue as well. That's in their documentation. They recommend not to do that.
Yeah, you don't want to double wrap, but you can nest things.
Yep.
Yeah, so yeah, go for it.
One thing I did come across, there might be a bug with the PBS in terms of spawning it across multiple nodes. That seems to be a known issue, which I'm not sure is resolved yet. So maybe Slurm doesn't have that problem, but PBS maybe does.
I think Slurm also has that problem.
Right.
So I think there is a workaround, and this is not something that I've explored too much, but I think that there is an MPI Dask job queue something that's been started, and that might be, if you really need to be working across multiple nodes, what we need to start looking into.
Yeah. It seemed a little complicated to work around, so it was like it fires up the first. I think it comes to when you start your cluster. If you request like say 3 nodes, it fires up 3, but only one of them is actually doing anything, and the other 2 are just kind of idling, but still kind of taking up resource. Well, still being booked out, if you like, on the scheduler, but not actually running.
Right. And this is a known issue? Like, has it been documented in the Dask job queue repo?
I've seen it on like Stack Overload. Yeah.
Yeah, I would also check out the GitHub repo and see if there's anything in there. Because I know that like the Dask community for the most part communicates like on GitHub. And so, yeah, that's probably not a bad place to check or add an issue. Yeah. And so feel free to like fire off questions. That notebook that I dropped in is a little all over the place, but I'm happy to try and create a bit of a cleaned up example if that would be helpful.
Yeah, it might be useful just to have kind of like a minimum example of like how to wrap the bits that you've had to wrap in a function, and then how you've called that kind of stuff.
Yeah, for sure. That's a good call. Yeah, I'm happy to put that on my to-do list for next week.
Lindsay, did you have to get some help from the nurse? I was just curious, like if you're using like whatever Dask provide, as like suppose like there's a PBS cluster or a Slum cluster, like did the nurse have to do something for you, or because like when I was working on here, we have a C's, and then they had to do something on their end to make that work. But I think here, I think they're not that many Dask users, and so I think I couldn't actually I couldn't succeed to run Dask on multiple cluster here. So I was just kind of curious, like did you have to get some help from nurse, or it was already fine?
There was minimal documentation, but I didn't actually, like, once I sort of figured out enough of the things and poked around with the functions, it was working for me. So I didn't actually have to like ping nurse staff and ask them to change anything.
Right.
So, and I think I installed Dask. So I had enough control over my environment to conda install Dask. So I didn't have to actually ask them for anything to get this going.
Right. Okay. Right. Gotcha.
But are you using Dask job queue or just Dask?
No, I was using Dask job queue, and I was using PBC cluster, but
Yeah.
Dask provided. I think that I did something wrong, I guess.
There's a handful of examples out there, but I think that like this isn't all that heavily hit on yet. So it's entirely possible you did things right, and it just like the setup is a bit more challenging there. So yeah, if you're still running into issues and you think it's on the Dask end, I mean, I think feel free to file an issue, and I'm sure there's people who would jump in and try and help out. Cool. All right. Is there anything anyone else wants to chat about this week? Silence.
I could show later about what I've done for airborne code, because like it seems like John and Don may want to jump into DC code. I think there are probably quite a few analogies I guess we can make. Yeah, I ended up using like a SciPy regular interpolator, which was pretty fast. So I was like just using regular tensor, like a regular mesh, which is having exact same mesh size, but local mesh is octree. So in that way, so I can be quite flexible. So I could even do like a 2D to 3D interpolations, or 3D to 3D interpolation. Yeah, like that was an okay solution to me. But I think, for DC probably it may not be the case. So, but there are quite a few analogies that we can make. But other than that, I think that I was pretty pleased like that Dask is actually working for a very simple parallelization problem, which is supposed to work, I guess. But the writing part was important, which took a while to figure it out. Yeah, so, but I think if we're not really using the multiple cluster, it's not very exciting, because like then, I mean, why do I need to use Dask? Like there's other solutions. So yeah, I really wanted to make that work in a multiple cluster so we can actually scale that up. But yeah, I could show like sort of what I've done.
I think the advantage will be in the parallelizing at multiple levels, right, without having to insert multiprocessing everywhere. For instance, like if you're storing your projection matrix, then the operation of projecting your model onto your local mesh can be just a Dask delayed function, where the interpolation matrix lives on disk, right? And so is your forward modeling also, and then Dask will parallelize all the way through your operations, rather to have to like do multiple levels of multiprocessing. I think that's the main advantage.
Right. Yeah. I think we can do some like a sort of combination, because I think what you've done is basically matrix vector parallelization, right? So when you're generating the G matrix, you use ZAR to store it, and then when you do the matrix vector product, it's basically Dask.product. So that's the main portion of the parallelization, which is good. But I think a lot of like a nonlinear code, like a PD code, there are quite a few other computations required. So I think we can actually use a lot of ideas that you've already done, but I think there are probably some differences like that we need to make. One thing, like for instance, if we can pickle like a factorization, that'll be nice, because like then we really don't need to pass like a heavy step, but just load it up whenever you need it and do a solve, for instance. So there are quite a few things like that.
That'd be awesome, Sagi. Would you be game to do that next week?
Yeah, I could. I could show what I've done, and I could put some thoughts on it. What could be a good sort of direction that we're going? And Joe, I was just kind of curious that the volume averaging step. Can we put that topography in? Because currently it's like a mesh to mesh, but like usually what we need is I want to move from active cells to active cells. Is that going to be simple for you to kind of implement that?
So you just basically don't want to include the inactive cells in the operation?
Correct.
I mean, it should be just fine as long as there's if you have the map, it should be just fine.
I found the easiest way to do it, Sug, is just, and probably it's going to be for you too, Joe, is create your large projection matrix, and then just cut the columns and rows corresponding to the air cells, right? So that's your active set interpolation, basically.
Yeah, what could be the worst case? Because like, let's say you have air cells, and then if you're simply doing like a linear interpolation or volume averaging, you're gonna interpolate between air cells into the Earth cells, which is not great. So I mean, that's like sort of the main reason why we sort of like want to move from just the active cells to the other active cells.
Well, we're already doing this operation in the regularization meshes, right? We have our full gradient operators, and then we're just cutting the rows and cells that are inactive.
Correct, but like but the current implementation, what Joe did for volume averaging is an entire mesh to entire mesh. It's not you cannot put active cells to active cells. So I was just asking how complicated it is.
I would assume you can just multiply by a simple projection matrix on the right and left side to get to do what you need. Like just a matrix that goes from active to inactive and fills it with zeros.
Yeah, I'll actually test it, because I was worried about like the surface will have like some artifacts, because
but I'm not sure how you would get around.
Exactly. Okay.
Well, you'll need to normalize your rows for the volumes, right? So if you chuck out cells because you did a projection, you need to renormalize your volumes to make sure that the total sum ends up being the total volume. You know what I mean?
Yeah, I think so, but I don't see why it would change by making some cells zeros. Like it's not really the volume averaging operation is not dependent on the values of the cells.
Yeah, I'll make some test example and see if what it does. I haven't tried yet. I was just worried about because it seems like just mesh to mesh. So, but I'll test it.
Excellent. And Sagi, are you going to present that next week? To present your AEM stuff?
Yeah, I
Okay.
could. Yeah, I could show.
Excellent, excellent. Perfect. Okay. Well, oh, the last thing that I wanted to check: are folks okay if we roll back again to 2 p.m. Next week, or is this now a conflict with 350?
It's going to be a conflict with 350, and especially next week is going to be the MAG lab, so it's possible that Devon, Mike, and myself going to be away for the meeting too. Well, next week, even like it's like the field one, so it's probable that we're not going to be back at UBC before 3:30-ish because we have to come back from breakage. So maybe in the morning even, maybe the morning would be better.
Okay.
Or another day.
All right. We can start like a poll or something like that to figure out a time. I mean, is this like only next week is also problematic, or this is now problematic for the rest of the semester?
Well, we're just only helping Devon through the first 2 weeks. So that just means that after that, it's only Devon that's not going to be here. But so if it's more comfortable for everyone, well, it's only Devon. But next week, it's probably going to be a lot more. At least we can at least see for next week, like because next week it's a lot more of us that's going to be away during a good portion of the afternoon. But 350 lab is always from 1 to 3, but it's only this week and next week that there are several people.
How about Wednesday? Is Wednesday a good day for you guys? Because I'm at UBC only Monday and Wednesday now. It's more convenient for me, but I'm just throwing it out there.
That's fine. I teach from 1 to 2, but other than that,
I can do between 2 and 3 on Wednesdays, but I can't do any later than that.
2 to 3 on Wednesday sounds good to me.
Yeah.
2 to 3 on Wednesdays? Okay. Well, let's give that a try. And yeah, we can go from there. Excellent. All right. See you guys.
Everyone.
Thanks, everyone. See you later.
Yeah.